Farnborough International 2004 took place against a background of continuing uncertainty in the commercial aircraft sector and also in some major military programs. There were even discussions in the press about the viability of Farnborough itself. Despite all that, 243,000 people came to the show to see new features like the International Space Pavilion. American companies were there in force after they'd boycotted Paris in 2003. And we begin with a long-lived American success story, the Lockheed Martin F-16.
We've built over 4,400 of these F-16s worldwide, not just at Fort Worth, Texas, but at other locations around the world as well. There's been 20 air forces around the world that have flown this airplane. It's still in service in the majority of those air forces, and we'll continue to build this airplane probably through at least 2008 and 2010.
Troy Pennington talks us through his display.
This particular year, we've added some maneuvers on the fly, but what we do is show off the performance and the capabilities of the airplane that any F-16 pilot is capable of doing, and we just do it in a very low altitude and close fashion to the crowd so we can enhance the show appearance and make the airplane as real as we can. But we're going to do a maximum afterburner takeoff. We're going to pull the airplane straight into the vertical and climb to about 2,000 feet, roll the airplane over to the side and do a split S maneuver. We'll get down to about 125 knots, 140 knots at the very top of that, pull the airplane back down, come across the show line from left to right, do one barrel roll, which we've added this year, do a split S maneuver at the other end of the show line, and come back across the show line and do a series of inverted to inverted passes. Inverted passes show the airplane nimbleness, if you will, as the airplane rolls from upright to inverted and then back to inverted again and then turn away. The maneuvers we do after that are a series of turns and high G maneuvers, which we want to both show the power of the airplane, the nimbleness and the simplicity of flying the airplane, and also the capability of the airplane, again, that really any pilot can do. One of the maneuvers we do is a slow speed pass. We've added 2 years ago a barrel roll entry, which we've enjoyed so far. And as we turn on the show line, we roll the airplane into a barrel roll and slow the airplane down to about 120 knots or so. We get the airplane pretty close to the limiter of the airplane at 26 degrees angle of attack, and it makes a quite good effect with the smoke winders as the airplane is flying across right to left on the show line with the smoke winders the smoke trailing up from the wingtips. We finish that with a full afterburner vertical climb. It's an impressive maneuver because we've come by at minimum airspeed. We light the burner, we add about 20-30 knots to the airplane, climb to the vertical, and then we do a series of rolls that looks like the airplane is out of control, but in fact, it really is just simply a loaded roll that makes the airplane look really unsafe, but it is not. We finished the show with a couple of maneuvers that have been trademarked for the F-16. One of them is a high-speed pass coming in at about 380 to 400 knots, and then we do a 9G level turn at the very end of the show. The 9G level turn has been a trademark of this airplane for many, many years, the G capability of the F-16. And at the end of that particular maneuver, we come out, roll the airplane's wings level, pull the nose straight up, and do a figure 9 at the end, and then we turn to downwind, put our landing gear down, and land.
On February 24th, almost 1 year to the day after major assembly operations were started, the first production C-130A was towed off final assembly to the Lockheed production flight line. Many advanced features by Air Force and Lockheed designers went into this, America's first turboprop air freighter.
Seems hard to believe that this splendid airplane here is actually a 50-year-old airplane.
You know, I tell customers and prospective customers time and again that it is so amazing that an airframe that's 50 years old with the infusion of modern technology is now the most modern cockpit in the air today. This is a whole new way of doing business for aviators. We have taken the airplane over in all of its aspects and turned it over to the mission computer. So I don't even look at engine instruments anymore. Major emergency procedures are now automated, so I concentrate on the precise control of the airplane now and never worry about the machine. For the average person who looks at the J model, the first thing they're going to see, and about the only thing unless they get in the cockpit that's going to look different, is the 6-bladed propeller up there. What that gives me is an increase in thrust without an increase in fuel flow. I'm the same power output as the H model or the K model, whichever version you might have been flying, but I now have more thrust for the same power rating. Any pilot who has ever flown the Herc has developed a particular love and affinity for this machine. I mean, you can put great big holes in it, it doesn't matter. It brings you home every time. It is just an extremely rugged and durable airframe.
The C-130J on the static display came from the United States National Guard, but it was the Royal Air Force's new Hercules C-130J that was in the flying display. Seen here doing a steep approach and a tactical landing. The RAF has actually got 25 of these aircraft. They replaced half of their fleet of the older K models. The Royal Air Force was the launch customer for this type of aircraft, and that was reflected in the fact that they had some early engine problems which have now been resolved, and the aeroplane is operating successfully in the front line. So what are the current real interests in the aviation world?
I think if you look around this show, it's not the sort of traditional platforms of fighters and bombers and reconnaissance aircraft or even airliners. And people here are coming to see the unmanned aerial vehicles. This is the first show where I've felt that UAVs and UCAVs, and the armed versions of the unmanned drones, are actually starting to take a prominence.
The program for a US Navy and Air Force combat UAV is known as JUCAS. I spoke with Christopher Hernandez about Northrop Grumman's competitive tender, the X-47B, which was at Farnborough in the form of a mock-up of their proposed US Navy vehicle.
UAVs have been in the past used as strike systems. The Predator system has a strike capability, and even the Army Hunter system is going to get a capability to drop armament on ground targets. The JUCAS program sort of takes that to a whole nother level. It's an advanced airfoil. It has low observable features associated with it. It has very advanced sensors, much like we find on an F-18 today. And it's the integration of those sensors and these advanced weapons in this new airframe that makes the distinction between JUCAS and things that have been done in the past.
Bringing an unmanned combat vehicle into land on a ship clearly presents some unique challenges to the JUCAS contenders.
We have the VTUAV, the vertical takeoff UAV for the U.S. Navy, which is a helicopter, which also must land on a rocking ship as it's underway. This is something that we'll demonstrate later this year with the VTUAV and the USS Swift, which is an experimental ship that the Navy has. So there are technologies, mostly in the microwave area, that are used to synchronize the position of the ship and the UAV and to essentially force these two to come together. Similar technologies exist today on the F-18s that land on aircraft carriers. Those technologies will be what we use on JUCAS to ensure that it can land directly onto the carrier and grab that third wire.
Are these machines going to take over completely from pilots?
No, I don't ever believe that unmanned vehicles will take over completely from pilots. And even today, the way Global Hawk operates, we have pilots in a control system environment monitoring the aircraft, monitoring the sensors, and helping to help the system figure out what it should be doing. The future will see more and more UAVs and systems that like them that integrate with the battle space, but I see for many, many years, decades to come, that unmanned systems will be an augmentation to the manned systems that we currently have.
Now, we haven't yet seen any of these flying at an air show. Are they safe to fly in civilian airspace?
Certainly. As a matter of fact, Global Hawk is the only unmanned system today that has a certificate of authorization to operate in federally controlled airspace in the United States. We've flown Global Hawk to Australia, we've flown it to Alaska, and we've flown it to Germany. Of course, it's served time in Iraq and Afghanistan, so it is able to operate safely in a variety of airspace control systems.
The There were several business jets at Farnborough. This is a Gulfstream G4. But these aircraft do other things than pure business travel. They're more technologically advanced than you might think.
The attributes that make Gulfstream a superb business aircraft, its reliability, range, altitude, flying above where the regular commercial airliners fly, its reliability, its accessibility in smaller airports where commercial airliners can't go, all those attributes have adaptations for other uses. For example, the National Oceanographic and Atmospheric Agency uses a Gulfstream G4 as a hurricane tracker. There are medevac varieties of Gulfstreams, and one of the lesser known applications is the Gulfstream G2, which NASA has adapted, and every single space shuttle pilot is actually trained on a G2. It can deploy its thrust reversers in flight and simulate the rock, which is the shuttle when it's coming in for a landing.
But now you've got some even newer technology, which you've adapted for your newest aircraft, this so-called EVS.
Gulfstream has come up with one of the most modern state-of-the-art cockpits called Plain View, and incorporated in Plain View is an enhanced vision system for the pilot to be totally aware of what's going on, not only in flight, but equally important if you're landing and it's foggy and misty and you're not sure who else is out on the runway. With the enhanced vision system, you can actually pick up other aircraft or vehicles on the runways and avoid runway incursions.
Now, one of the problems, of course, with corporate VIP flying is security, and companies are always worried about that. You have some enhancements in that field.
Well, we do have some enhancements. We have a video system on board which enables you, when you're on the ground, to see anybody that's getting close to your aircraft. Also on display here, we have our IRCM, our infrared countermeasure system, which defends against ground-to-air missiles. Without getting into too much detail as to how it actually works, the system makes the missile believe that the aircraft is somewhere else.
And here's an aircraft that takes self-defense even more seriously. One of the 4 crew members in this B-1B Lancer bomber does nothing else but run the self-defense systems. This aircraft is from the 34th Bomb Squadron at Ellsworth Air Force Base in South Dakota, and it's flying by here with its wings swept fully forward, a demonstration of the variable sweep back. 4 huge General Electric turbofans, more than 30,000 pounds of thrust from each of those engines. A much smaller aircraft now, but still a bomber, although it's actually called a fighter. This was the world's first operational aircraft to exploit stealth technology. It is the F-117A Nighthawk from Lockheed, and it's been in United States Air Force service for 22 years. It hit the world's headlines the first night of the First Gulf War when it took Baghdad by surprise. And now to Airbus. I talked with test pilot Peter Chandler about displaying one of the world's biggest airplanes.
It takes a little bit of getting used to, not because there's any problem with handling the airplane, but just because it's not the sort of thing that you would normally do with that airplane. But certainly things like the low-speed pass with a big airplane, I think looks impressive, and it would be difficult to do with an airplane where you didn't have such reliable flight control system protections. The airplane is at fairly lightweight for this display, and it starts with just a normal full power takeoff, and once the airplane's safely airborne, I then just pitch it up to 30 degrees pitch up, and that is a protection that's in the flight control system, because in airline service there's never any normal requirement to go beyond that. So 30 degrees nose up, and then I turn off to the right. Here at Farnborough there are some very strict rules about display line, so it's important to move out to the right to get onto the display line. From that, I turn back then towards the crowd and just come back down to just below 1,000 feet to then start a left-hand 360-degree turn. And during the turn, again, I'm not using the full bank authority of the airplane at all, only about 45 degrees of bank. We're just climbing during the first part of the turn and then descending down during the second half of the turn, back towards the crowd centre. And from there, I'm setting up for the low-speed pass. And this is something which is where I really am using the protections of the flight control system. So as I turn out, keeping the speed fairly slow, and then in this case turning back to the right onto the display line, but trying to keep the speed right back as slow as possible, so that when I roll out of that turn, I can very quickly go to full back stick, so that I'm basically letting the stall protection system of the flight control system hold the airplane at the maximum angle of attack, so the minimum speed, the maximum angle of attack, and just controlling the height then with the power. And then I fly down the display line at very slow speed, and it's around 110, 115 knots, something like that. At the end of the low-speed pass, then it's full power again to start the climb up to turn downwind. The turn again, not really using the full capability of the aeroplane, but just a turn downwind, but climbing again at the maximum pitch angle, so 30 degrees of pitch. And what I try to demonstrate just at the end of that turn is going basically from one of the pitch limits to the other, so 30 degrees of pitch up, and the limit if you pitch down is 15 degrees. So by going at slow speed, full forward stick, I can actually get it to go from 30 degrees pitch up to 15 degrees pitch down. And we put the gear down, turn downwind, and turn in for a landing. And again, the landing is just a normal landing.
By the next Farnborough in 2006, we could be seeing an even bigger passenger aircraft display. I asked Daniel Carnelli to update us on the progress of the A380 that continued to dominate the headlines at the show.
To date, the A380 is on track for a first flight in the first quarter of 2005. The first delivery to the first customer is also on track for the second quarter of 2006. The first prototype aircraft has been rolled out of the factory in Toulouse. So we're no longer talking about a paper aeroplane, we're talking about solid metal now.
You are now the only people in this segment of the market. Nobody else is making a big aeroplane. Now, how did that come about, do you think?
Our competitors are focusing on the Boeing 787 at the moment, which is not a competitor to the A380 at all. They compete in two totally different market segments.
So I asked Mike Baer, who's head of the 787 program, to give us the Boeing view of the commercial marketplace.
Well, there's no question there's a market for a big airplane. In our view, it's very small, and it's small enough that we could never justify the kinds of investments that would take to build a big airplane like that, as opposed to the type of market that we see here in the middle of the market, which is just enormous. When we look at it, we see about 3,500 airplanes that are really starting to become 20, 25 years old, so it's the start of a major replacement cycle. There's about $400 billion worth of business, so a very sizable chunk of the commercial airplane market. A really fundamental push forward that we're making on this airplane is the use of composites. For the first time in the history of commercial aviation, all of the primary structure is going to be made out of reinforced graphite epoxies. That's a material set that we have a lot of experience with. We love aluminum. We've had 50 or 60 year run building aluminum airplanes, but this material is ideally suited for jet airplanes, and it's the wave of the future.
We're sitting here in this mock-up of the cabin. Is this representative?
Yes, this is what the interior of the airplane will look like. One of the things that we are doing on the 77 is really trying to focus on their cabin environment. You'll notice that it's a very spacious looking interior, very open. You'll notice is the size of the windows. They're 30% larger than any other window in service today. People really like to look out when they're flying, and with these windows and the openness of the cabin, no matter where you're sitting, you'll be able to easily see out of the airplane. We're also trying to make sure that the environment inside the cabin is as pleasurable as possible. We're lowering the cabin altitude of the airplane so that you have more oxygen inside the airplane. We're going to increase the relative humidity, so at the end of a long flight, you'll notice the difference. You won't be nearly as dehydrated, you won't be nearly as tired as you are in today's airplanes. So some really significant advances on the interior of the airplane in order to make it really a passenger-pleasing environment.
Mostly due to the efforts of a South African 747 pilot, Boeing were kept in the public eye at Farnborough with a rare 747 flying display.
The laws of physics are the same whether if you're flying a small aircraft or a big aircraft. One of the things that a lot of people do remark on and that we feel hinders us a bit is the view that you have out of the cockpit. When we're sitting in a 45 or 60 degree angle of bank turn towards the airfield, we actually can't see exactly where the airfield is. So there's got to be a lot of coordination between the two pilots, because obviously if you're in a right-hand turn, then it's the guy on the right-hand side who's got to be watching, and he's cueing me on how to turn and how to keep going, etc. We come from the southeast of the airfield. There's a turn descending across the airfield fence at about 1,500 feet down to the 600 feet allowed here, in a steep turn to the right. There's an immediate turn reversal then with a climb in the turn up to 2,000 feet on the opposite side of the airfield, descending back again in that turn towards the display datum, which is just in front of the control tower behind us.
880, 840. 740, 700.
We then continue that turn and then pull up into a wing over, turning left back towards the airfield again, descending back to that same display point datum again.
Keep turning. 800, stop pulling. 700, 600.
The top of the right-hand wing over, we extend the gear where the crowd can't see the gear being extended, so the first time they see the gear is when the aircraft is approaching them, as if it was in the landing configuration. Down to the minimum height allowed here again, we take go-round thrust and we do this towering spiral that we call it, where we get very high body angles and high angles of bank. Hoping to move away from the crowd as we fly in this spiral, and the guys in the radar tell me that blip hardly moves on the radar screen, so it's virtually vertical the way it goes up. And we climb up to an altitude of 10,000 feet there.
So next it was back to Heathrow for Captain McAlpine to take on passengers and head to Cape Town. Another Boeing product next, not quite as big as the 747, but even older. The B-52 bomber first flew in 1952. And believe it or not, they'll still be in service in 2044, 92 years after it first flew. An extraordinary record. Now, this aircraft arrived from its base at Minot in North Dakota directly into the display on the Tuesday. Well, not quite. Unfortunately, at the end of their long trip across the pond, the crew overflew Blackbush Airport, 5 miles to the northwest and across the M25 from Farnborough. Red faces all round. But they did find the right airfield for the rest of the week when they were based at Fairford in Gloucestershire. Welcome back to Farnborough, where the old sits comfortably with the new. The RAF Battle of Britain Memorial Flight never fails to stir the emotions with its Lancaster, Hurricane and Spitfire. And it's one of the RAF's oldest squadrons, number 17, that has taken delivery of its latest aircraft, the Eurofighter Typhoon, but not without some delays. We spoke with Ian Buston about Typhoon's halting progress into service.
Well, in the last year, since June 30th in 2003, Eurofighter has really taken a major step forward. We got our type acceptance, which was crucial to allow us to deliver to the Air Forces in the summer last year. And since then, the aircraft's come into service. At present, we've got 24 jets with the 4 nations in Italy, Spain, Germany and the UK, and they're all actively involved in both the operational evaluation and the training of pilots for the future Eurofighter Typhoon squadrons.
Eurofighter has always seemed to be behind the times and over budget. It seems to have had a lot of problems. Are we sort of beginning to see those problems disappearing?
The Eurofighter program is Europe's largest military program, covering some 620 multi-role jets that will be in service for 50 years. It's inevitable a program of that magnitude would suffer some delays, there would be budget issues, and more importantly, there would be political issues. I think we've addressed those, and we're past that now. And really, it's time that we stop looking at our shoes and look at the aircraft that's been delivered, because the results from the pilots are simply outstanding. And for the first time at Farnborough, we have an Air Force jet with an Air Force pilot doing the display, and we're very proud of that.
And I took the opportunity to speak with one of those Air Force pilots.
From a pilot's perspective, Typhoon is an extremely exciting aeroplane to fly. It's very easy to fly. I suppose your grandmother could fly it. You just pull a stick back, pull a stick forward, roll it left and right. There are no limits, essentially. Fly-by-wire system provides us with total protection, essentially, so we can do what we like, which is not the case, say, with earlier marks of airplanes. I started flying on the Lightning, where it was a bit of a seat-of-the-pants experience. Lovely to fly, but much more challenging. This is not remotely demanding from a flying perspective, which means we can concentrate on operating the aeroplane, which is the thing that matters. We're at the start of a very, very involved process in order to be able to declare to the Commander-in-Chief that Typhoon is ready to take its place in the front line. Given that we've only flown a couple of hundred hours on the aeroplane, we have about 10 pilots converted to type. It's not going to be as quick as some people might think. It's not a question of the aeroplane arriving on the flight line and then being declared as ready to undertake its task. So it will take longer than people imagine.
What about the display here at Farnborough? Talk us through that a little.
In a technical sense, from a Royal Air Force sense, a display would involve things like rolling upside down, carrying out aerobatics, etc. We don't do any of that. It's a bit of noise and some fun for the crowd. If you like, the roll demonstration of a sort that we fly here just very quickly showcases the performance of the aeroplane in terms of acceleration, a little bit of its low-speed capability, the carefree handling aspects, and its turning performance. Unfortunately, until probably next year, you won't see a full-blown aerobatic display from a Royal Air Force aeroplane flown by a Royal Air Force pilot.
And with only 10 pilots trained on type, it's not surprising that Typhoon displays are pretty rare. So Typhoon still has testing times ahead, but other fourth-generation aircraft have been in service for some years. I spoke to the Saab chief test pilot about the Gripen and how the company can keep its aircraft ahead of the new competition.
I think what we do is to try to maintain a step ahead with integrating and are integrating all the latest weaponry that you can find with laser-guided bombs. We'll be the first aircraft to fire the Meteor missile next year, and we're integrating a helmet-mounted display. We're also doing updates to it's a spiral update really from the human-machine interface. So I think we're staying ahead.
What other air forces are now using the Gripen?
Gripen is now used by the Swedish Air Force, but the South African, the Czech, and the Hungarian Air Force will take delivery soon. And right now we have South Africans flying the aircraft in Sweden as test pilots.
Magnus Olsen talks us through test pilot Fredrik Muchler's Farnborough 2004 display.
Friedrich Michelin's display this year is different. There's new regulation, and the regulations keeps getting a bit tougher and tighter all the time. So he's had to do quite an extensive change to his program. The minimum flight altitude is higher this year. The box is smaller. The way he is allowed to point his aircraft towards populated areas is quite restricted. So I think what Frederick is trying to show how Gripen doesn't lose its energy in a high G turn, in a high G maneuver. A few other aircraft doing displays here, and you can see that they have high angles of attack and they lose their speed. They recover it, but with Gripen, he does a 9G, a very steep 9G turn, and he keeps the speed all the way through and can pick up again. This aircraft can keep its speed throughout a fight, and not like older generation where you actually lose speed and have to go lower and lower all the time because the big delta makes you lose your speed. So I think that's what he's trying to show. I think it does it very well.
Gripen is in operational service, so you must have picked up a lot of experience that these other aircraft that are coming along haven't been able to do yet.
We've amassed about 50,000 flying hours. And from the Air Force in Sweden, we've been fed a lot of data and a lot of feedback that helps us staying ahead, that we feed into later software editions. And really, it's a software aircraft, so although hardware often gets the publicity, it's the software that makes the aircraft.
So how do you see the future then for Gripen?
Swedish Air Force will operate it for 30 years, and customers will operate it just as long, and we will keep developing it, keep making it better, and do software updates, integrate new weapons. And as we've seen with the helmet-mounted display, with the Meteor missile, with other external equipment, Gripen is the only aircraft that can take them. They're modern, we're modern, and the others aren't.
As the Gripen lands, its canard wing at the front looks like nothing so much as a pair of elephant ears, slowing it down using aerodynamic braking. Now, the Joint Strike Fighter will be the next generation jet, and members of the different nations of the JSF consortium were at the show to sign a bit of metal. And this chunk of expensive signatures will actually go into the first JSF aircraft.
This way, please. This way. This way. Good. And again.
Now, this is a sad occasion. After this year, it's the end for these fascinating aeroplanes. The last squadron of the Royal Navy's Sea Harriers disbands in 2005. As a stopgap, the Navy gets some of the RAF's Harrier GR7s and 9s. The difference is that these naval fighters can protect the fleet. They're air defence aircraft, real fighters, and they have the Blue Vixen air-to-air radar, which the other Harriers don't have. So the Navy gets a ground attack fighter without a radar in the interim. How long? Well, the only possible replacement is the Joint Strike Fighter, but that won't be till 2012 at the earliest, another 7 years, and even that may not necessarily be a short and vertical takeoff version. And why are they doing this? Well, it's because these Navy Sea Harriers are the older, less powerful type of Harrier, and it would be too expensive to give the Harrier 2 version that the RAF and the US Marines have an air defence radar. So, here is 899 Naval Air Squadron from Royal Naval Air Station Yeovilton in their last big fling, reminding us perhaps of the first ever 4-ship Harrier display at Farnborough in the late 1960s. The Navy put on display 2 two-seat trainers and 2 single-seat naval fighters. And this aircraft is in the hands of Lieutenant Commander Stinger Ray. He's the senior pilot on 899 Naval Air Squadron. He's taxiing the aircraft into the Rolls-Royce enclosure, because of course the Harrier has a Rolls-Royce Pegasus vectored thrust engine. And Rolls-Royce has this enclosure at the show this year because they're celebrating their centenary. They've been in business for 100 years. And they have various aircraft on display in the enclosure with Rolls-Royce engines. I spoke to Rolls' chief test pilot. Now, you're the chief test pilot for an engine manufacturer. That sounds slightly strange to the untutored ear.
It does, very much so. But what it means is that I work very, very closely with the airframe manufacturers. So I work with BAE Systems, I work with Boeing, I work with Airbus, I work with everyone and anywhere that we integrate on our aero engines.
So you get to fly a lot of different aeroplanes?
I do. It's a tremendous job. I'm very privileged and very lucky. I don't want for flying As you say, many different types, lots of variety, from the Spitfire through to the Airbus to the Boeing. It's a tremendous job.
So what's it like to fly something as exciting as a Spitfire at one of the world's premier air shows?
Fabulous, absolutely fabulous. It's a great privilege, that's the way I feel, to be part of Rolls-Royce, but also to be sat in a Spitfire at an air show like Farnborough International. Flying the Spitfire is always tremendous fun. You know, at some point you'll look out at the wing, that classic shape, and you'll giggle childishly. It's tremendous, great privilege. I'm flying the Rolls-Royce Mark 19 Spitfire, which is powered by the Griffin engine. Very similar development of the Merlin engine, moved on towards the end of the war with the Griffin. More powerful, very different to the Merlin, but a tremendous engine nonetheless to sit behind. And with the Spitfire, a fabulous combination. It's a very measured display, as I think it has to be with the Spitfire. It's such a classic airplane and an old airplane that you're not displaying yourself. I'm not demonstrating what I'm capable of. It's just to show those classic lines of the aeroplane. And what I'm doing is starting with a top surface pass, just to show that classic surface, top surface of the airplane, turning it around and showing the classic underneath, and that, once again, that beautiful elliptical wing, using up to 3, perhaps 4G in some cases, depending on the wind. And then I use a half horizontal, which is half of a loop, allows me to turn around and go back the other way, which helps very much with the airspace here at Farnborough, because it is quite tight and packed airspace. And I finish with a victory roll, as you'd expect.
Vintage aircraft from a different era now, the jets this time. These 3 are from Kennet Aviation. The Jet Provost 1, that's a prototype, leads. The Nat Trainer in original Red Arrows colours and with an original Red Arrows smoke system. And the Hunter FGA 6. Hunter first flew back in 1951. Undoubtedly the most successful post-war British fighter, a single-seat day interceptor fighter. 13 nations other than Britain bought this aircraft. And Britain used it for the Royal Air Force and the Royal Navy. It was the RAF's mainstay fighter until the arrival of the Lightning in 1960. One of the show highlights was test pilot Ricardo Traven's display in a Super Hornet fully loaded with dummy missiles. I asked him about displaying the aircraft in this configuration.
We've chosen at this Farnborough to demonstrate the aircraft with a rather impressive load of 6 air-to-air AMRAAM missiles, radar missiles, and 2 heat-seeker missiles. A loadout that most airplanes can't even carry, let alone do any impressive maneuvering with. The equivalent weight of the missiles with the pylons is similar to carrying an SUV strapped to the bottom of the airplane. And that's what we're trying to show is the Super in Super Hornet. I have, in this configuration, no limits. I can do whatever I want with a stick in any direction. I have unlimited angle of attack range and virtually no limits on the throttle. And so the maneuvering is carefree. And what you see in the display is showcasing that capability. I'm literally throwing the stick and the throttle in all directions, showing the agility of the airplane with no limits.
So what you're saying is the computer systems won't let you crash it?
Oh, the computer systems will definitely let me crash it. But I will crash it. It won't be a case where the aircraft goes out of control. And so I have no worries whatsoever in my display that the aircraft will let me down. I have to make sure I don't let the aircraft down.
And the first startling thing about his display is the takeoff run. It's about 1,000 feet. Thrust into the air by 2 General Electric turbofans, more than 44,000 pounds of thrust in reheat. And as soon as he gets airborne while the wheels are still down, he's able to do a roll through 360 degrees. And you can see the heavy load of the missiles there, as Ricardo said, weighing more than a large car. He pulls the aircraft up into what he calls a half Cuban 8. It's sort of 3/4 of a looping maneuver, and on the way down, he rolls the aircraft the right way up. Now he does something that many aircraft can't do. He gives a very rapid pull-up. That's 9G, his body weighing more than 9 times its normal amount. But then he pushes the nose down again. He calls this the turbo pitch down. It's getting the nose pointing in the right direction again. Lots of very high G turns here, putting himself under a lot of pressure, the aircraft as well, but demonstrating its extraordinary maneuverability. We also get to see how the tailplane maneuvers the aircraft. This aircraft doesn't have ailerons. The tailplane works differentially, so as he goes into a bank here, you see the thing twist. Slowing the aircraft down with this roll and yawing and pitching all at the same time before he comes by in a high alpha, slow speed fly past. And in fact, this combination of Ricardo Traven and Boeing's FA-18 Super Hornet won 3 prizes at an air show the week before Farnborough, the Royal International Air Tattoo. There were lots of rumours and gossip at Farnborough 2004 about the future of the event as a major air show. I asked Paul Beaver for his impressions of the show.
I think Farnborough's changing. It's no longer the Farnborough Air Show, it's now the Farnborough Business Show. If you look around the chalets, with some sort of 1,300 exhibitors there from just about every country that's in aerospace in some way. This is very much a business show, and it has a bit of an air show tacked onto it during the business days, and of course it has the pageantry on the public days. So it's a change. I think it's probably, you could say that this is one of the milestone Farnboroughs because it is the first one where I felt that I'm now going to a business show, no longer going to an air show. It's not really, I don't think, the vintage Farnborough air shows that I can certainly remember as a child in the 60s, and certainly we were used to seeing in the 70s and 80s.
Farnborough, 1959. The Society of British Aircraft Constructors' 20th Flying Display. With this year's emphasis on Britain's aim to maintain a place in the civil airliner market. These planes, it's hoped, will cut the fares and make flying possible for millions.
And of course, that was an era when Britain was actually building its own aircraft, like this Victor, for instance, made by Handley Page. Nowadays, the British aviation industry is almost entirely taken up with collaborative projects with other countries. Now, here was an extraordinary aircraft, a short SC-1. It was a vertical takeoff demonstrator. It actually used vertical lifting engines, unlike the Harrier, and this particular concept was never very successful.
Then, like puppies at play, the dashing and the cavorting of 4 hunters, each with a variety of underwing stores.
And unlike today's comparatively distant demonstrations, these aircraft displayed at considerably less than 600 feet.
The sky seemed full of hunters, and then suddenly it was. 22 of them from 111 Squadron doing that fabulous formation loop. Six peel away, leaving 16 to do a row.
And from Squadron Leader Latham's magnificent Hunter formation to today's modern equivalent, the Red Arrows were the mere 9 aircraft. Not only that, but their trainer aircraft are not frontline fighters, a reflection of the expense of using frontline fighters for display these days. Here, the Reds are in the shape they call the Gripen. The Red Arrows, one of the few full-time professional formation aerobatic teams in the world, pulling up here for their Champagne split. Sends a tingle down the spine, doesn't it? Hard men take the stage now, the synchro pair, doing their opposition manoeuvres. Squadron Leader Dave Thomas, Red 6, Flight Lieutenant Dan Simmons, Red 7. And that tank under the Hawk there, that's where they keep the diesel fuel that makes the smoke, red, white and blue. And we'll let the Red Arrows close our show for today. The Red Arrows in their 40th anniversary year, under the command of Red 1 Squadron Leader Spike Jepson.